Maths is awesome, maths is fun, maths is there for everyone. Welcome back, Year 8 students, to our second lesson on measurement. Today we're going to be talking about the perimeter of circles. Now the perimeter, when you're talking about circles, has a special name. It's called the circumference. Now, there are four concepts that we need to understand when we're working with circles. The first thing is, what is circumference? Well, circumference is the distance all the way around the outside of a circle. It's also called the perimeter. Oh, bumped the change of colour there. But it's called the perimeter. We don't normally refer to it as perimeter when it's a complete circle. Now, the second thing we need to know is, what is a diameter? Well, a diameter is a distance across a circle that passes through the centre. And I'll show you in a moment. But if you have a circle with a centre, diameter goes from one side across to the other. There's your diameter drawn in. A radius is the distance from the centre of a circle to the outside. It doesn't matter where. There you go. There's the distance from the centre to the outside. That's called the radius. That line there is called the radius. This one. And the last thing we need to be aware of is this Greek symbol. It's called pi. Now it's a letter from the Greek alphabet that we use, and it's used in the formula for circles. You can actually find there is a button on your calculator that has pi next to it. If you actually look right down in the bottom row, it's the middle button in the bottom row, you'll have in gold writing a little pi. And if you hit shift and then that button, that will put pi on your calculator screen. Now, your calculator screen will give it to more than 5 decimal places, but there is what pi is to 5 decimal places. Pi is a really strange number. It's called a transcendental number. You don't have to remember that, but you do need to remember it is a decimal that goes forever. No one has ever found the ending to pi. There's no pattern and there is no ending. There are some people who have remembered it to thousands and thousands of decimal places. We have one student in the school that's memorized it to over 200 decimal places. So it's a big number, but you can just use your calculator. Now, there are two formulas when we're dealing with circumference of circles, and it depends. You'll notice this circle, I'm given the radius. In this circle, I'm given the diameter. If I'm given the radius, I always use the formula C, the circumference equals 2 pi r. So use the 2 pi r formula if you know the radius of the circle. However, if you're given the full distance across the circle, you can use the formula C equals pi d, where d is the diameter. And let's just think about this for a second. If I look at this circle on the left, I'm going to draw in an extra line. That distance from there to there is also the radius. If I look at this particular question now, if I wanted to go from one side all of the way across to the other, I've got 2 radiuses. And 2 radiuses are the same as the diameter. So if I see this 2 and this r, there's my 2 radiuses. That's the same as just having one diameter. And that's why the two formulas are the same. Let's have a look at our first example. Correctly show the following on the circles. What's a radius look like? Well, we've already talked about that. And there's an example of a radius. Now, I could have gone anywhere, from the centre to anywhere on the outside of the circle, and that would be correct. What does a diameter look like? Well, a diameter goes through the centre of the circle from one side to the other. And I could have gone anywhere as long as it goes through the centre, going from one side to the other, then it's a diameter. What's the circumference? Well, the circumference is the distance around the outside. So I'm actually going to colour the whole circle red. And there it is, the distance around the outside. That's the circumference. And what is the centre? Well, the centre is this little dot right in the middle of the circle. That's the centre of my circle. Now, example 2 says find the circumference to 2 decimal places. Well, for this question, I know halfway across the circle. That's called the radius. So I'm going to use the formula that has 2 times pi times radius. If I put this into my calculator, 2 times pi, remember to access pi, look in that bottom row on your calculator, push shift and then that middle button on the bottom row, and you will access pi, and then times 5, push equals, and you get a big long answer. Now I don't want that answer. You'll notice I didn't put an equal sign here. I've actually put this sign here is called approximately equal to. That just tells me that there's more decimal places, I just didn't write them. So that's correct up to there, but there are more numbers to go after it. Question said to give the answer to 2 decimal places. Now if I give the answer to 2 decimal places, then I need to look at it, and I need to go 31.41. Let's look at that next number's a 5, which means my 2 decimal places have to go up from 41 to 42. And I should actually have a meters on the end as well because it's in meters. Let's go to part B. Now for this question, I know the distance all of the way across the circle. All of the way across is called a diameter, so I'm going to use the formula C equals pi times diameter. Now we know how to access the pi button on the calculator. What is the diameter? Well, the diameter for this question is 20. So it's just pi times 20. Put that into the calculator. I don't need to write that line. I'm just showing you for the first 2 examples that I get decimals that go for a long time. I only go to 2 decimal places, it says. So after the decimal point, 8, 3. Need to look at that next number. It's a 1. Because it's a 1, I'm not going to bounce that 83 up to an 84. The answer is 62.83. Again, I forgot to put the meters in. And there's my circumference to 2 decimal places for both of those circles. And remember, these little signs are pronounced approximately equal to. It just tells you you've rounded off. Now, for our next example, we're doing something a little bit different. We're going to use, instead of the pi button on the calculator, we're going to use pi as 3.14. This goes back to before we actually had a pi button on the calculator. We didn't have that button, so we used to just enter in approximations for pi. Now we know pi to 2 decimal places is 3.14. Sometimes I'll even ask you to do this. I'll say use pi equals 22 over 7, or 3 1/7. But rarely will we ask you to do that nowadays, because that's what pi is closely as a fraction. It's not the exact answer, it's approximately. So just be aware that sometimes the questions won't ask you to use the pi button on your calculator. They'll ask you to actually use a specific value instead. So if we look at this particular question, pi is equal to 3d. Now this question says to find the perimeter of the circle. Well, another name for the perimeter of a circle is circumference, and we know the circumference of a circle when we're given the diameter is circumference equals pi d. Remember, circumference and perimeter are the same thing if we're talking about a full circle. So for this question, it becomes the perimeter equals not pi anymore. I'm going to use 3.14 instead of pi. I don't need to write that line there. Now I have rounded it because pi is an approximation. It's not exactly 3.14. But if I put that into the calculator, that's about 314 centimeters is what the perimeter is. And there's our approximation. For example 4, now we can't use the word circumference for this question because it's not a full circle. It's actually a half circle, which is called a semicircle. So I'm going to introduce you to a formula that we can use when you're dealing with semicircles and part circles, and here it is. To find the perimeter, what we always do is we add up any straight bits, which is this bit here, and any curved bits. Very technical formula. You won't find that formula in your textbook. I've just made it up. When you're dealing with these sorts of shapes, deal with the straight bits and then we'll deal with the curved bits. Now, for this question, the straight bit's easy because we know it's just 18. So the straight bit is easy. The curved bit is a bit harder. So the straight bit we know is 18. The curved bit is half of a circle, half of the distance around a circle. Now I know the full distance around a circle is pi times d. So if I put a half in front of it, a half of pi times d will give me the distance halfway around a circle. Why did I use the pi d version? Because I know the distance all of the way across my semicircle, and that's the diameter of the full circle. You also notice I put brackets here. You don't need to do that, but I do that often because the first bracket means that's the straight bit, and the second bracket means that's the curved bit, and there's a plus sign between them, so I just at a glance know that they're two separate parts of working out. So my 18 is easy. A half times pi times the diameter is 18. I now just have to put that into my calculator, and if you didn't use the brackets, you'd still get the correct answer. If you just wrote 18 plus a half times pi times 18, the calculator will give you your answer. And if I round it to 2 decimal places, and that's why I've put this little symbol here to say that I rounded it, the answer is 46.27 centimetres. Make sure you do put that into your calculator and that you can generate that answer. Some students just assume when they're first starting they can do that and realise, oh, I'm not quite as confident as I thought, so make sure you can. Part B, perimeter of this shape. Well, same deal. I'm going to do the straight bits and any curved bits, and I've got to find the distance around the shape by adding up all the straight bits and adding up all the curved bits. Well, the straight bits, there's one and there's another. Because they've both got dashes, remember, if I continued this around, it would look something like this, a very poor attempt at it, of a circle, and that would be the centre of the circle. So this 2.3 is the radius of the circle if it was all there. I've only got a quarter of the circle drawn. Now, when I deal with this question, that straight bit and that straight bit is 2.3 plus 2.3. They've got dashes, that means they're the same length. So there's my straight bits part. I could, because this is a quarter of a circle, I could have gone a quarter times pi d, but this time I've gone a quarter, because it's a quarter of a circle, times 2 pi r. Now why did I use 2 pi r? Remember, if I had a full circle, that 2.3 is not all of the way across, it's only halfway across. The radius would be 2.3. So I've just gone for the formula to use the radius. Now, if I put that into my calculator, 2.3 plus 2.3 plus a quarter times 2 times pi times 2.3, and I should have written it there, I don't know why I didn't, I get an answer of 8.21. And remember, I've rounded that. Let's go to example 4. Let's find the perimeter of this shape. Well, the straight bits plus any curved bits. Well, what you need to do with this particular shape is realise that there's a straight bit, there's a straight bit, there's a straight bit. What I want you to imagine is there's a line going across there, and I've now got a straight bit, a straight bit, and a straight bit, and a curved bit. So let's just take those bits off. So my straight bit, and straight bit, there's 3 dashes, so they're all 12 plus 12 plus 12. This bit is half of a circle. Well, half of a circle, the distance around half of a circle would be a half of pi d. Remember, pi d gives you the distance around an entire circle if you know the diameter. Now for this question, do I know the diameter? Well, I actually do. How do I know the diameter? Well, the diameter is the distance all of the way across the circle, which matches up with that length there, so the diameter is 12, and that's why I've put a 12 there. So I put that into my calculator. 12 plus 12 plus 12 plus a half times pi times 12, and I get an answer of 58.85 centimetres if I round it to 2 decimal places. Why have I got that symbol there? That's approximately equal to tell you that it's been rounded. Now for part D, this looks like 3/4 of a circle. So perimeter is the straight bits plus the curved bit. Well, that's a radius, so the 2 straight bits will be 6.3, and that is 3/4 of a circle. So I've got 6.3 plus 6.3 plus 3/4. Now I could have used pi d, but this time I used 2 pi r because I know the radius, not the diameter. Put that into my calculator, 6.3 plus 6.3 plus 3/4 times 2 times pi times the radius, which is 6.3. And I get to 2 decimal places, 42.29 centimetres. You should be checking these answers on your calculator and making sure that you can round them correctly and that you are in agreement that those are the answers. If you do check them and you don't get the answer I'm getting and you're not sure why, let me know and we'll figure out why. Okay, now example 5. Rearrange the formula C equals 2 pi r, so r is the subject. That means I need to get r by itself. Remember, this is C equals 2 times pi times r. How do I undo a times 2 and a times pi? I divide by 2 and I divide by pi. So I'm going to divide both sides by the 2 and the pi. And if I do that, the 2 and the 2 cancel, the pi and the pi cancel, which means I'm left with C over 2 pi equals r, or r equals C over 2 pi. R is now by itself. That is your answer, or it can be written like that. For part B, it says rearrange the formula C equals pi d. So d is the subject. Well, this is C is equal to pi times d. If I want to get d by itself, it's being timesed by pi. What's the opposite of timesing by pi? Dividing by pi. If I divide both sides, the pi's cancel. I'm left with C on pi is equal to d, which is my answer. D is now the subject, or you could rewrite it as d equals C over pi. Well, time for you to try some questions. Enjoy the experience, and if you do have any problems, please let me know so we can figure out how best to get you to understand it. Bye for now.